When observing the world around us, we often make statements about what we see and perceive. Like, the sky is blue, the clouds are moving quickly, or the cars are honking and the noise is driving me nuts. Statements that include numbers or relationships often are mathematical in nature. Two common types of mathematical statements are equations and inequalities. These statements contain expressions of quantities or values. The simplest mathematical expressions are single numbers, such as 8 or 25, or variables, such as x or y. Expressions may also include operations, such as addition, as in 5 plus 7, or x plus 17. Every equation and inequality includes not only two expressions, but also a symbol that represents the relationship between the quantities represented. In an equation, the symbol is always, you guessed it, the equal sign. In inequalities, you'll often see the symbols for less than or greater than. Let's look at an equation. There are rhombus-shaped panes of glass on the entrance to the famed Louvre Museum in Paris. If we use the letter S as a variable to represent the number of panes, we can write that statement as a numerical equation. Look around. You don't have to be in France to express the world in mathematical terms. Try your own backyard. You could say your brother is nice or that he bugs you, but you'd have trouble turning either statement into a mathematical equation. However, the sentence, my brother is 3 years younger than I am, can easily be expressed mathematically using subtraction. It means, my brother's age is 3 years less than my age. Using the variables b for your brother's age and a for yours, we can write b equals a minus 3. That's a mathematical equation to represent that your brother's age is equal to your age minus 3 years. Or, your brother is 3 years younger than you. Now a little equal time for inequalities. What if you want to say that your brother is shorter than you without saying by how much? That could be written as x, your brother's height, is less than y, your height. Let's explore more ways to express quantities and relationships in the world with math in mind. Destination, London, England. It's a place bustling with people and boasts all kinds of attractions. But we're here on business, with an aim to express a few of its characteristics mathematically, with expressions and equations. A preferred way to get around town? London's black taxis. In the year 2005, there were about 20,000 of them in the city. We can express the number of taxis mathematically with a very simple expression, the number 20,000. In 1986, there were only 14,000 taxis rolling through London streets. The simple expression for this would be the number 14,000. We can express the change in the number of taxis with a more complicated expression using subtraction. 20,000 minus 14,000. Let's call this difference D and write an equation that says D equals 20,000 minus 14,000. The value of the expression on the right is 6,000. So we can write an equivalent equation as D equals 6,000. These equations are two ways mathematically to represent the change in the number of taxis in London between 1986 and 2005. Destination, Paris, France. The heart of the City of Lights counts more than 2 million inhabitants. If you included suburbs and satellite cities, the greater Paris population is 11.5 million people. ranking it as one of the biggest cities in the world. If we want to talk about the population of Paris mathematically, we can. Using the variable p to represent the population of Paris in millions, we can write a simple mathematical equation stating its value. P equals 11.5. We can also use a variable to represent an unknown quantity in an equation. If there were 11.5 million total, and 2 million of them were living inside Paris proper, how many people were living outside the city limits? Considering millions, the total is 2 plus how many? Let's represent the mystery number with the variable m. So, 11.5 equals 2 plus m. You can easily see that for this to be true, this equation must also be true. 9.5 equals m. 9.5 million people live in the greater Paris area, but outside the city. Destination, New York, New York. The Big Apple. It's a very busy, very big place. In fact, it's the largest city in the United States, with a population of more than 8 million people. New York boasts 578 miles of waterfront and 10 landmark bridges, including the famous one linking Manhattan and Brooklyn. If the capacity of the Brooklyn Bridge, the amount of weight it can safely hold, is 18,700 tons, how many cars can cross it at one time without a problem? Good question. Let's start by writing an inequality statement that expresses how much weight in tons can be on the bridge safely. W is less than 18,700. W represents the total weight in tons. This inequality statement tells us there is a safe range. Basically, any weight less than the bridge's capacity of 18,700 tons. If you were to assume that the average weight of a loaded car is 2.5 tons, a reasonable estimate, you could figure out how many cars weigh 18,700 tons by dividing 18,700 by 2.5. It's 7,480 cars. We can use that value in another inequality. If only cars, no trucks, were on the bridge, the maximum safe number would be 7,480. So, using the variable c for the number of cars on the bridge, you could say that to be safe, you would need this inequality to be true. C is less than 7,480. The safe number of cars on the bridge is less than 7,480. Using the size of the bridge and the number of lanes, you could figure out that there's no way you could even fit 7,480 cars on the Brooklyn Bridge. Due to the design of the bridge, the inequality would always be true, and the bridge would be safe from being overloaded with cars. So hats off to the engineers who designed the super safe Brooklyn Bridge.